Welcome everyone. We are discussing circles. Today I will discuss general equation of circle and its application. We know equation of circle whose center is at alpha beta and radius r can be put in the form x minus alpha whole square y minus beta whole square equals to r square. Now if you expand x square then y square, arranging, this is 2x alpha minus 2y beta plus alpha square plus beta square minus r square equals to 0. Now we can write it in this form: x square plus y square plus 2gx plus 2fy plus c equals to 0. So look, this part alpha square plus beta square minus r square, it is constant. We are considering this as c, where alpha equals to minus g. So look, this is minus 2x alpha. So alpha equals to minus g, beta equals to minus f, and c equals to alpha square plus beta square minus r square. Now, what is r square? R square equals to alpha square plus beta square minus c. So what is alpha? Minus g. So g square plus f square minus c. We want to express r in terms of g, f and c. That is in terms of unknown of equation 1. Now x square plus y square plus 2gx plus 2fy plus c equals to 0. It is called general equation of circle. Now, what is the center? Center is alpha beta. So here center alpha beta. So this is minus g minus f. What is the center of the circle 1? Minus g minus f. And what is radius? Radius is g square plus f square minus c with root over. So we can find center and radius by these two formulae. Now, what is the advantage? So look, here we can find equation of, this is equation of circle. So if circle is given, so we can find its center by comparing. Look, coefficient of x, divide coefficient of x by 2, divide coefficient of y by 2, 2f by 2, this is f. Then change the sign. We get equation of circle. Now, x square plus y square plus 2gx plus 2fy plus c equals to 0. Center minus g minus f. Radius r equals to g square plus f square minus c equals to 0. So this is our working tool. Now if r equals to 0, if radius is 0, if r equals to 0, then it represents a point circle. Represents a point circle. If r greater than 0, then it represents a real circle. That is, you can draw it. If r less than 0, it is imaginary circle. So you cannot draw it, imaginary circle. So we have to remember this result, only how to find center and radius. In previous class, to find center, I have to express equation in this form. Then we are finding center and radius. But if we use general theory, it will take minimum time. Now application. Now how to find center and radius of circle. Now problem number 1. X square plus y square plus 6x minus 8y minus 24 equals to 0. Find center and radius. Look, if we compare it with general equation of circle, then we get 2g equals to 6, 2f equals to minus 8 and c equals to minus 24. So center minus g minus f. So 3 comma minus 3 comma 4. And what is radius? G square plus f square minus c. So this is 9 plus 25 plus 24. Minus plus, and so we are getting 3 square. This is 9 plus 4 square. 16 plus 24. This is minus. So 25, 24. So this is 7 root over 49. So look, how to find center and radius. Shortcut rule. Divide coefficient of x by 2 and then change the sign. Divide coefficient of x by 2, coefficient of y by 2, then change the sign. So we are getting center. Then radius equals to g square plus f square minus c. Mind it, coefficient of x square and y square must be 1. So what is center? Minus 3, 4, radius 7. So we can write the center directly using this one. Now problem number 2. Now 2x square plus 2y square minus a sin theta into x minus a cos theta into y minus a square equals to 0. Find center and radius. Now if we compare it with general equation of circle, then it is not of standard form. Standard form is coefficient of x square and y square must be 1. So this is x square plus y square minus a by 2 into sin theta minus a by 2 into cos theta into y. So here it is into x minus a square by 2 equals to 0. Now it is in standard form. Therefore 2g equals to minus a by 2, 2f equals to minus a by 2 and c equals to minus a square by 2. So center minus g minus f. So a by 4, a by 4. Now coefficient, a by 2 sin theta, a by 2 cos theta. Center a by 4 sin theta, a by 4 cos theta. Now look, divide coefficient, if it is standard form, divide coefficient of x by 2, then change the sign. So a by 4 sin theta, this is a by 4 cos theta. And what is radius? Radius equals to g square plus f square minus c. So 8 square by 16 sin square theta plus a square by 16 cos square theta minus c. What is c? c is a square by 2. So this is a square by 16 plus a square by 2. So 16 LCM. So 16 LCM. So 8 square plus a square. So 9a square. So 3a by 2 is 3a by 4. This is radius. Now this is our main aim. How to find center and radius in minimum time. So listen again. Divide coefficient of x and y by 2, then change the sign, you get center. And radius r equals to root of rg square plus f square minus c. So this is our basic tools. Now we apply this theory to practical problems. Now we consider two simple applications 1 and 2. Prove that center of the circles are collinear. This is problem number 1. And number 2, prove that radii of the circle are in AP. So, application of circle. How to find center and radii. So, consider problem number 2. X square plus y square equals to 1. So, 1 square. So, what is radius? This is given in standard form. So, R1 equals to 1. So, center 0, 0, radius 1. Now, equation of second circle, minus 2x minus 6y minus 6 equals to 0. So, g equals to minus 1, f equals to minus 3, c equals to minus 6. So, what is R2? G square plus f square minus c. G square plus f square minus c. Now put the value 1 plus 9 plus 6. So 16, that is 4. So radius is 4. Now third circle, x square plus y square minus 4x minus 12y minus 9 equals to 0. So g equals to minus 2, f equals to minus 6, c equals to 9. So what is the R3? R3 is g square plus f square minus c. So 4 plus 36 and c equals to not 9, this is minus 9. So this is 40, so this is 7. 40 plus 9, 49, so 7. So what are the radii? R1 equals to 1, R2 equals to 4 and R3 equals to 7. So look, difference of radii, 4 minus 1, 3, 7 minus 4, 3. So difference of radii is constant. Therefore, they are in AP. So this is problem number 2. Prove that radii of the circle are in AP. So how to find center and radius? Now problem number 1. Prove that centers of the circle are collinear. We have to find center. Now, circle number 1. Minus 4x minus 6y minus 12 equals to 0. So, what is center? C1. C1 equals to 2, 3. Divide coefficient of x and coefficient of y by 2. Then change the sign. C2. This is minus 1 minus 2. And C3, all are in standard form. This is 5h. So we are finding the center of the circles. Now we have to prove centers are collinear. You know, you can prove collinearity by different method. By finding area equals to 0. Slopes are same. Then equation of line passing through 2 points, third point satisfies it. If it satisfies, then they are collinear. So it will be simple if we find slope. So FC1, C2, slope passing through C1, C2. So difference of coordinate, -2, -3, y coordinate, difference of x coordinate. -2, -3, -1, -2, -1, -2. So this is 5 by 3. Now M C2, C3, 8 plus 2, 8 plus 2, 5 plus 1. Difference of y coordinate by difference of x coordinate. 10 by 6, 5 by 3. So slopes are same. So C1, C2 parallel C2, C3. Now C1, C2, C1, C2 and C2, C3, they are parallel. One point is common. One point is common. So figure must be of this type because point C2 is common. So C1, C2, C3 are collinear. So they are parallel since point C2 is common. So they must be collinear. So if slopes are same, then points are collinear. So it is direct application of finding center and radius. Next. Now application problem number 3. Find the area of equilateral triangle inscribed in x square plus y square plus 2gx plus 2fy plus c equals to 0. And area of equilateral triangle inscribed in this. This is problem of Wbjee. Now an equilateral triangle is inscribed within a circle. So equation of circle is given. Now ABC is an equilateral triangle. Inscribed within the circle. We have to find area of equilateral triangle. Now circle is given, therefore we can find radius. OA equals to OB equals to OC. So this is general equation of circle. So we are getting g square plus f square minus c as radius. Now to find area of equilateral triangle, you have to find side of equilateral triangle, that is AB or BC or CA. Now look, this one is equilateral triangle, so this is 60 degree. So OA is radius, OB we know, OB bisect is, so this one is 30, this one also 30. So we find first what is OD. Height of equilateral triangle, that is AD. AD is AO plus OD. So you know OA, you have to find OD. Now sin 30 degree, if we consider this right angle triangle perpendicular from center bisect it, sin 30 equals to OD by OB. So what is OD? OD is OB sin 30. So sin 30 is half and OB is radius. G square plus f square minus c. Now what is height? Height is AD. AD equals to OA plus OD. So OA is root over G square plus F square minus C. So G square plus F square minus C plus half of root over G square plus F square minus C. So 3 by 2 root over G square plus F square minus C. So we are getting height. Now we have to find side. Now consider ABD. This total angle is 60 degree. ABD. So entangle ABD sin 60 equals to AD by AB. AD by AB. So what is AB? AB equals to AD by sin 60. Now what is AD? 3 by 2 root over G square plus F square minus C, and sin 60 is root 3 by 2. So we are getting root 3 into G square plus F square minus C. So we are getting side of equilateral triangle. Now what is area? Area equals to root 3 by 4 into side square. So root 3 by 4 into 3 into G square plus F square minus C. So you have to recall this formula: G square plus F square, 3 root 3 by 4 G square plus F square minus C. So what is area? Area is 3 root 3 by 4 G square plus F square minus C. Now look, what is area of this? Area of the equilateral triangle inscribed to this circle. Now what is G? G is minus 1, F is minus 2, C is minus 20. GFC. We are getting GFC. So what is area? Area equals to 3 root 3 by 4 G square plus F square minus C. So 3 root 3 by 4, 1 plus 4 plus 20. This is 5. So 15 root 3 by 4 square unit. It is 2 marks problem of Wbjee. So today, through this class, we have learned how to find center and radius of circle and its application. These are very simple problem. So in next class, I will discuss more application of this theory. So thank you.